Hi, this is Bruce with Z Group Energy and a brief overview of how ZGE's sealed geothermal energy system works. We're often asked how sealed versus open geothermal energy harvesting differs. While not intuitively obvious, it is straightforward. Imagine a very simple conventional geothermal power plant at ground surface. You can see one in the slide here. Nearby is a return well. You see that on the left in red, with a perforated bottom section drilled into a hot, permeable, water-saturated layer of rock. The return well takes in heated below-ground fluids, sometimes referred to as geothermal brine, and delivers it to the power plant to drive a steam turbine, the turbine in turn driving a generator producing electricity for the grid. Now also nearby, and you see it over on the right there in blue, is an injection well used to inject cooled condenser fluid from the power plant back into the below ground reservoir, or in many cases, additionally injecting fresh water to replenish the below ground reservoir, which can become depleted if brines are withdrawn faster than can be naturally replenished. So there you have a basic conventional, what we call a two-pipe system with injection and return wells harvesting liquid or steam from a more or less open below ground reservoir. Now, imagine taking this entire conventional two-pipe system and just flipping it upside down with the reservoir on top at ground surface instead of far below. The ground surface reservoir now sitting on top of the harvesting system is called an exchange chamber, and you can see that in the sketch there. Imagine the exchange chamber being sealed as opposed to the difficult to control underground reservoir, which is open to surrounding cracks and fissures running in whatever directions those cracks and fissures run. Now, the sealed chamber up on top is fed by a pressurized cold water intake at one end near the bottom of the chamber. In this case, it's over on the right in blue. This cold water intake supplies water from a mixing tank, not shown in this sketch, discharging both recycled condenser water from the power plant and any added fresh water replacing system losses due to evaporation, leakage, and mechanical bleed-off. There are, with the sealed above-ground reservoir, no controlled below-ground reservoir losses to contend with. Now at the other end of the exchange chamber near its top, you see in this case up on the left there in red, is the discharge to a pressurized storage container, again not shown in this sketch, which is used for final temperature and pressure adjustment, in turn discharging to the power plant. Now, here's a page from the first page of the patent, and you can see here the mixing chamber. This is a diagrammatic sketch. You can see the exchange chamber is round. You can see it on the bottom left there in section, and you can see 7 heating cylinders going down. Over on the right, because you're looking in a vertical section, you only see 3. They overlap each other. And you can also see the pressurized storage container over on the left, and down in the bottom right, the exchange chamber and cylinders. Anyway, near the bottom of the exchange chamber are outlets. They're both to and from heating cylinders drilled deep into the ground, deep enough anyway to reach hot rock, preferably rock at supercritical temperatures and pressures. Each cylinder functions as its own non-partitioned injection return well. Open at the top, sealed at the bottom with no perforations, each well takes in cooler, higher density, fresh, clean water from the bottom of the exchange chamber, convectively discharging heated, lower density water back up to the exchange chamber. Now the cylinder heated fluids are heated conductively by the surrounding hot rock, Then, via convection, rise up to the exchange chamber, where commercial scale dynamic convective mixing occurs. Simultaneously, within each individual cylinder, cooler water from the bottom of the exchange chamber sinks into the non-partitioned cylinders to be heated. A convective pattern forms within each cylinder, eliminating the redundantly separate injection return well piping that we see in conventional two-pipe systems. Convective mixing within the exchange chamber at the top homogenizes the variable temperatures and pressures discharged from multiple heat cylinders. Variation in the geologic structure and the heating patterns below ground will result in each cylinder having slightly different temperature and pressure discharges at its top. Now, some cylinders will discharge more and some less, but the variable discharges from the multiple heating sources conveniently mix into one homogeneous blend ready for discharge to the pressurized storage container and finally to the power plant. Now, what conventional difficulties are resolved with this closed geothermal system? We'll just go through the list quickly. Only fresh, clean water is introduced to and recycled through the ZGE closed system. No geothermal brines are harvested, replaced, or depleted. Injection well fluid losses into the below ground reservoir are eliminated. Sealed system, fluid temperature and pressure are accurately monitored and controlled. No fracking is required as only heat from hot rock is harvested, never geothermal liquids or steam. Geologic structures are minimally disturbed by deep drilling, but no fracking is done, potentially destabilizing those structures. No corrosive or toxic brines are handled or need to be treated with the closed system. Overall, closed system water demand is a small fraction of conventional water demands. Electrical generation capacity of any conventional geothermal system can be increased at reduced operational cost and with less water demand using ZGE's sealed system. The closed system is not geographically restricted to tectonic plate edges or geologic singularities, but in fact can be used anywhere, only the drilling depth and cost will vary. The only environmental emission from the closed system is clean water. There you have it. Cost effective, zero pollution, sealed geothermal in a couple of slides. If you'd like to know more about ZGE's sealed system, supercritical geothermal, please visit our website at www.zgroupenergy.com. We would sure love to hear from you.